Imagine stepping into a machine. It hums with power. You press a button. The world dissolves around you. When you open your eyes, everything is different. The air is different. The sounds are different. You are in the past. Is this just science fiction, or could it be reality? Some believe that time travel is already happening. They point to unexplained events, strange stories, and blurry photographs as evidence. Could these be glimpses of time travelers walking among us? The idea of time travel is captivating. It sparks our imagination. It makes us question everything we thought we knew about time itself. What if we could journey through the ages? What if we could meet our ancestors or witness historical events firsthand? The possibility, however remote, is thrilling. We all experience time. It flows around us like a river. Seconds tick by, minutes turn into hours, days melt into years. Time in our everyday experience seems constant, unchanging. But what if this perception is an illusion? What if time is not a rigid, unyielding line? What if instead it's more like a winding river, speeding up and slowing down, bending and curving in ways we can barely comprehend? This is where our everyday understanding of time begins to unravel. To grasp the possibility of time travel, we must first confront the true nature of time itself. Our ancestors saw time as linear. It was a straight path from the past, through the present and into the future. But then came Albert Einstein. His revolutionary theories of relativity shattered our old ideas about time. Einstein showed us that time is not absolute, it is relative. Einstein's theory of relativity is like a key. It unlocks a deeper understanding of the universe. One of its most startling revelations is the concept of time dilation. Time, Einstein showed, is not the same for everyone everywhere. It is affected by gravity and speed. Imagine two clocks, one stays on Earth, the other travels into space at incredibly high speeds. Einstein predicted that the clock in motion will tick slightly slower than the clock on Earth. This isn't a mechanical malfunction, it's a fundamental property of time itself. This phenomenon, time dilation, has been experimentally confirmed. It's not science fiction, it's a real phenomenon. Atomic clocks, precise to within a fraction of a second, have proven Einstein right. Time is not a constant, it's a variable, a fluid aspect of the universe. If time can be stretched and squeezed, could it also be folded? Could we create shortcuts through time, tunnels connecting different points in space-time? This is where the concept of wormholes comes into play. Imagine the universe like a sheet of paper. Now fold the paper in half so that two distant points touch. This fold represents a wormhole, a theoretical shortcut through space-time. Wormholes are still theoretical. They emerge from the complex equations of Einstein's theory of general relativity. However, these equations are notoriously difficult to solve. The mathematics of wormholes suggest that they are incredibly unstable, prone to collapsing faster than the blink of an eye. Section 5. Paradoxes of time, tangled threads of cause and effect. The idea of time travel is riddled with paradoxes. These are mind-bending scenarios that challenge our understanding of cause and effect. One of the most famous is the grandfather paradox. Imagine you travel back in time and accidentally kill your grandfather before your parent is even born. This creates a paradox. If your grandfather died, you wouldn't exist. But if you don't exist, you couldn't have traveled back in time to kill your grandfather. Another famous paradox is the Bootstrap Paradox. Imagine you find a copy of Shakespeare's Hamlet. You travel back in time and give it to Shakespeare himself, who then copies it and claims it as his own. Where did the play originate? You found it from Shakespeare, but Shakespeare copied it from you. It's a closed loop, a paradox of origin. Section 6. Chasing Shadows, the quest for a time machine. Building a time machine is a daunting task. It would require harnessing the very fabric of space-time, bending it to our will. While we haven't cracked the code just yet, scientists are exploring various avenues. Some involve manipulating extreme gravitational fields, like those found around black holes. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. These cosmic monsters warp time in extreme ways. Some theories suggest that approaching or entering a black hole might offer a glimpse into the future or even a passage to another point in time. However, getting close to a black hole is a risky proposition. The gravitational forces involved are unimaginable. A spacecraft venturing too close would be stretched and compressed like putty, a phenomenon known as spaghettification. Section 7. Echoes from Elsewhere, CERN and the Frontiers of Reality. At CERN, the European Organization for Nuclear Research, scientists are exploring the fundamental building blocks of the universe. Using the Large Hadron Collider, they smash particles together at incredible speeds, recreating conditions that existed a fraction of a second after the Big Bang. While not directly aimed at building a time machine, the LHC's experiments offer valuable insights into the nature of time and space. By studying the behavior of subatomic particles, scientists hope to unlock deeper secrets of the universe, potentially revealing new pathways to manipulating time itself. Some theoretical physicists believe that by creating microscopic black holes in the LHC, we might be able to open up tiny wormholes. These wormholes, though incredibly small and short-lived, could offer tantalizing glimpses into the possibility of manipulating space-time at a fundamental level. Section 8. Vanished. Mysteries across time. Throughout history, there have been countless stories of mysterious disappearances. People vanish without a trace, leaving behind baffling clues and unanswered questions. While most of these disappearances can be attributed to mundane explanations, some remain stubbornly unsolved. One such case is the disappearance of Amelia Earhart. In 1937, Earhart and her navigator, Fred Noonan, disappeared over the Pacific Ocean during their attempt to circumnavigate the globe. Despite extensive searches, no trace of their plane or their remains has ever been found. Some speculate that Earhart and Noonan might have encountered a temporal anomaly, a glitch in the fabric of space-time. Could they have flown through a wormhole or encountered a rip in the space-time continuum, transporting them to an unknown time or dimension? Section 9. Could they be among us? Proponents of time travel point to curious historical anomalies as potential evidence. Photographs from the past sometimes seem to show objects or people that seem strangely out of place. One famous example is the time-traveling hipster photograph from 1941. The photograph shows a crowd of people gathered for the reopening of the South Fork Bridge in British Columbia, Canada. One man in the crowd stands out. He's wearing sunglasses, a printed t-shirt, and a hairstyle that seemed decades ahead of their time. While skeptics argue that these anomalies are simply misinterpretations or hoaxes, the possibility, however remote, that these are glimpses of time travelers among us continues to intrigue. Section 10. Time travel, fantasy, or future reality. The possibility of time travel remains one of the most tantalizing and enduring mysteries of the universe. While the laws of physics as we currently understand them present formidable challenges, the history of science is filled with examples of once unthinkable concepts becoming reality. Will we one day build a time machine? Will we journey to the distant past or the far future? Only time will tell. But one thing is certain. The human quest to understand time, to unravel its secrets and unlock its potential, will continue to drive our curiosity and inspire our imaginations for generations to come.